Hello 108 students, Mr. McCue here. Hey, we're going to start section 10.4 on properties of logarithms. We are going to take care of page 1 here, and we're going to start going over some properties that are very similar and follow properties of exponents. And my first note up here says logarithms are a form of exponents, so the exponent rules that we know apply to logarithms. And so we're going to kind of run through them here. Over here in this box I've got the exponent rule that when you multiply by the same base you add the exponents. And how would that apply here in our case of logarithms? And first rule we're going to work on is the product rule of logarithms. Says that the logarithm of a product is the sum of the logarithms. Okay, now what we're going to work on here is I'm going to go ahead and write the formal rules down here and then give some examples to help prove these. It's going to take a little bit of work here to feel comfortable with logs and some of the properties and the shortcuts you can use. So we're going to start here, and I'll just try to walk through these with you. So start here. If you have a log of base b and the result is the product of x times y, you can expand that and say it is the log of the same base of the first product, and here's the key thing, plus the log of the same base of the second product. Okay, so that's what we've got going here. My next couple lines here, I'd like to offer an informal proof. I picked an example that I said, what would happen if you took the log base 2 of 32 and wondered if it would be equivalent to the product of 4 times 8, which equals 32, and if I broke it down and said it was the log 2 of the first product, which is 4, plus log base 2 of the second product, which is 8. Okay, so what I tried to do here was I took each side here and see if we can prove this. Now, a shortcut that you guys need to get comfortable with here is back here. It says log 2 32 of result 32. You got to get used to when you see the base and you see the result, what you want to do is ask yourself, take the base, which is 2, raised to what equals the result 32. That question mark is the exponent that is being represented by this whole expression up here. And when you answer that, you go 2 raised to the what is 32, and you come up with 5. Okay, so basically log 2 32 can be replaced with 5, and that's what I did here. Okay, going to take the same process and log base 2 result 4. Up here I did a little bit of work. I said that is taking the base 2 raised to what equals the result, and to answer the question mark you get 2. So we've got that placed down there. So log base 2 result 4, what is the exponent that makes it work? 2. Finally, we'll go over here to the second product, log base 2 result 8. I come up here and I said 2 raised to what exponent? That's what we're trying to find, equals 8 is the result. 2 cubed is the answer, and that's what I put over here. And so we've got the statement, does 5 equal 2 plus 3, and of course the answer is true, and there's our proof that we can follow that product rule for logarithms. Okay, now here in example 1a we got a couple examples I can work through here. Starting off with 1a, we got log base 5. Inside the parentheses they've got 6 times 9. If they'd put 63 in here, you would break it down into factors, 6 times 9, and therefore we're going to go ahead and use that product rule. So we're going to take log base 5 of the first factor 6 plus log base 5 of factor 9, and that's how you could break it down. That's the direct use of the product rule, and that's all you could do for that one. Okay, moving our way moving our way down to example B. This one you have to keep your eyes open here because these rules go in both directions. And so up here in my notes, well, you might think of it starting off with the results with products being separated into the sum of the products with logs. You also can go the other way, meaning if you've got an addition of the logs with the same base and two results, you can compress them back up into the product. And that's what is happening on example B here. So you look at this, a couple of things you got to remember. You must have the same base, which we do, must have a plus sign, which we have, and therefore I can compress it back into the log base 7, and the result is the product of 8 times 12. 8 times 12, which is 96, and that would be your answer there. Notice in my notes I say reverse direction. Okay. Now these examples are not too bad. It's just kind of recognizing them and just applying the product rule here. Example C, we've got log base 3, result 3 times x. Don't forget the multiplication in between. What does that equal to? I've got a product in the result, so I say it's the log 3 of the first product factor, 3, plus log base 3 of the x, the second factor. And then what's interesting, you go, ooh, don't forget our special rule that when you've got the base and the result is the same, 3 and 3, you can replace that with 1. We did that on the previous section. And the log 3 of x, you cannot do anything with it, and that would be your answer. Okay. So there you go. Now we're going to look at example D. We've got log base 4 raised to the product result x to the third. Now we want to study this. I want to look at this real closely. This is going to turn into a rule that we're going to use on page 3, so I'm going to explain it here. This is going to help us see what the shortcut is, but on page 3 when we get to it, it's going to be known as the power rule for logarithms. So let's see if we can work through the details here. As of right now, you see log, the problem has got log base 4, like I said, x to the third. I realize that x to the third can be broken down to log 4 x plus log 4 of x plus log 4 of x, because x times x is x cubed. Okay, so I've done that, and then the next thing I realize is, kind of like terms, I've got the same term, coefficient 1s can be popped up in it. And now if I was going to combine like terms, I'd add 1 plus 1 plus 1, and that would give me the 3, and then you'd have it times the term log base 4 result x. Now if you see this real quick and study it, you could start to see when we get to page 3, the shortcut is look at the exponent, look at the result, look at the exponent. When you see that, you immediately can say the answer is 3, which was the exponent, and then you multiply it by the log. Okay, so once you see the pattern, you can go straight down to here. You don't have to go through all the work there. Okay, that's all for now here. We finished up page 1. Going to go ahead and move on to page 2. I'll see you there.